Today we're looking at the optimization problems, essentially shading graphs once again, but based on very specific word problems. So I'm taking two problems from the textbook to help us understand this. The first one deals with apples and oranges. We are always asked to start by labeling our variables. Here A is apples. I'm using R for oranges because the letter O looks too much like a 0. We're told in this problem we must have at least 5 apples and we must have at least 6 oranges. So I've got a little scale set up here, and we're told one more thing: the number of apples and the number of oranges must be less than or equal to 700. I can rearrange this last equation and come up with a slope-intercept form way of looking at it. Or better yet, I can use the method that we used the other day finding intercepts, where we let R equals 0 solve for A, and let the A equals 0 and solve for R. The reason I like that method is because then we're able to very easily plot that information on the graph. So I'm starting out here with my apples must be greater than or equal to 5. I look up, I got my oranges are, this is approximate, but it's right about there, and my oranges must be greater than or equal to 6. That's shaded to the right. And then I use this last equation where the number of my apples that I'm putting together, the 20 and 35, remember from the problem, stand for the number of cents that they cost. I plot that line using these intercepts, and then we shade by using our test point 0, 0, and here we're shading underneath. So we end up with that little shaded common area there where we're going to be optimizing our graph. And this is a two-part lesson. So part 1 is this week, part 2 is next week. You'll see here I'm just filling in all of the possibilities. They're on the regular whole numbers, and the reason for that is you can't have half of an apple or anything else. So the actual answers would be those dots. Something the textbook uses that's called the objective function. This is the amount of fruit, and that's going to be equal to the number of apples plus the number of oranges. That's more for next day's lesson. Question 2 in the text. D is the number of hot dogs and H is the number of hamburgers. We're told the total number of hot dogs and hamburgers must be less than or equal to 300. We're told the number of hot dogs can be no more than 200 and the number of hamburgers can be no more than 150. There's our 3 equations. We're going to try and plot them on a graph. So let's set up our lines. And again, our numbers are fairly large with 300s, 200s, etc. So when we go to our scale, we would want to use these bigger numbers. I'm choosing D to go on the x-axis, H to go on the y-axis. It really doesn't matter which way we do it. If I use the process of letting D equals 0, therefore H equals 300, letting H equals 0, therefore D equals 100, I get the green line that I've just drawn. The other 2 lines are similar to our A and our R from the last problem. This time when I'm shading, I'm trying to do it in such a way that we can see a little bit more clearly what area gets shaded in. That's common to all 3, and that's this area that I'm highlighting right here in yellow right now. Again, we need to figure out a objective function, and it's just that's going to come into next day's lesson. So here I've got the amount of sales. This is going to be equal to each hot dog costs $3.25, each hamburger the $4, and etc. You've got a little bit of homework. It's the exact same sort of setup as these 2 problems. That's all I want you to try this week. Question numbers 3 through 5. I want you to show all of your work. And I also want you to jot down some thoughts on your homework before you submit it. I know that we'll be talking about this quite a bit in our upcoming Zoom session, so please have attempted these 3 questions by then, and I will see you on Wednesday, everybody. Thank you.